We've talked about maps and sets for the last couple of weeks, and now it's time to talk about weak versions of those two data types. Weak maps and weak sets are not so called because they have puny little child arms. You do not need to shout, "Bro, do you even lift?" as you employ them. What the weak is referring to is how the keys and or values are referenced. We'll explain that in a second, but first we have to talk about some significant differences between the weak and non-weak versions of these collections of data. You may remember with maps, our keys can be anything, a string, a number, even a function. Not so with weak maps. Their keys can only be objects. Keep in mind that lots of things in JavaScript are objects, including arrays and functions. Anyway, this code won't work. Go ahead and save, refresh, and it throws an entire error that stops our JS execution. So the way to fix that, if we wanted to continue with this, is to wrap it in a try-catch block like this. Now when we continue, we can actually continue executing script even with that error happening. Anyway, if you want your weak map to actually work, try this. Save, refresh, test value. By the way, if we try to log this, it's going to give us undefined as I typed in the comment, because it never actually worked. Note that, as this example makes apparent, values can be anything, strings, numbers, functions, etc., but the keys have to be objects. For weak sets, there's a similar rule. The entries must be objects. So, again, you can't do this. That's going to give us an error. Throw it in a try-catch block. Save. Now we can keep running. So instead, we need to do something like this. Save that. True. Note that we defined obj up here. So why all the insistence on objects? The answer is garbage collection. Hang on for a sec, we're about to go kind of deep into how applications work in a way that a lot of JavaScript programmers literally never have to deal with. When the JavaScript engine is evaluating your code, it ends up having to store a lot of stuff in memory. For example, and we're keeping this simple, the actual process is a bit more complex, if you have an object with a bunch of properties, those properties are stored in memory for quick and easy access as the code is executing. When you overwrite that object later with an empty object, those old property values no longer exist, so they're no longer needed, so they get removed from memory. That's garbage collecting in a nutshell. Again, the actual process is a lot more nuanced. JavaScript handles it automatically, which is why many programmers never really need to think about it in a way that, say, low-level machine code programmers need to. Hooray, web development! However, this also means that the JS engine's not always sure whether it's going to need values, and it may keep stuff around that's not actually needed. So if you want to be more explicit in your memory management, you can use Weakmap and Weakset to explicitly tell the JS engine, hey, as soon as the objects stored here are no longer referenced elsewhere in the code, clean them out of memory. There are all kinds of uses for this, one of them being handling private data that should only be accessible to a particular function rather than the broader code base. One good use of this would be not having to trust people consuming a public API to ignore methods or data you've designated as private. You can make them actually private. One last thing to note about Weakmap and Weakset. They are super not iterable or enumerable. This, again, has to do with garbage collection. By introducing references to what the Weakmap or Weakset contains, you're requiring that data to be kept in memory in ways that defeat the purpose of not just using map or set. So none of these following pieces of code will work. Let's try that. Nope. WM1 is not iterable. How about this? Nope, that method doesn't exist. And this? Nope, that method doesn't exist either. So, yeah, look, I understand that most of this tutorial was telling you what you can't do with Weakmap and Weakset, but that's only because they behave very differently from much of the JavaScript stuff we encounter on a day-to-day basis. Gotta compare and contrast them against something, right? You may never have much use for either of them in your code, but if and when you start dealing with public-private data concerns or large applications with gigantic memory footprints that need active management, you may well find that the value they offer is very real. Better to know about them and never need them than to need them and never know about them. Next week, we're on to a new topic. What will it be? I have no idea yet, but I'll see you then.